Number 13 can kind of be a tricky one if you don't really think it through here. We've got a dice, so there's 6 outcomes each time you roll. The first part asks for rolling any number and then getting that same number. The second one asks for rolling any number and then not getting that number. The first part is probably going to be the trickiest part, not the second part. The first part is we can roll any number, okay? But we're not going to pick out which one it is first, okay? I couldn't say like, well, the number we're going to get is 4, so it'd be a 1 out of 6 chance, and then to get the same number would also be a 1 out of 6 chance. We can get any number to start with, so actually, this is going to be one of those certain probabilities. It's going to happen every single time. So I would actually get a 6 out of 6 chance to start both of these, because I can start with any number. Now, here's where they're going to change. This time I have to get the same number. And to get the same number that I had here, whatever it is, it's going to be a specific one number. So that would be actually 1 out of 6. If I multiply those together, I'm going to get 6 out of 36. If I reduce that down, divide by 2, no, we can go bigger than that. Divide by, how about 6 goes into both of those? It's just going to be 1/6. I got a 1/6 chance after I reduce this 636 down of getting any number and then getting the same number back to back. Now down here, probability of getting any number and then not the same number back to back. If I think about that, getting a different number than I got the first time, I've got 5 choices of numbers that are going to be different than the first time. So instead of 1 out of 6, I can go all the way up to 5 out of 6 because I just have to make sure my number is different than the first one, and I have 5 choices that are going to be different than the first one. Times those together, I'm going to get 30 out of 36. Reduce that down, 6 goes into both of those. 30 divided by 6 would be 5. 36 divided by 6 would be 6. I've got a 5/6 chance. So I've got a really good chance of not getting the same number back to back. I've got a pretty poor chance of actually getting the same number back to back. There's a lot of kinds of dice out there. Most people see the 6-sided dice, but there are a lot of sided dice. I know that this question for number 14 uses an 8-sided dice. If you've ever played categories before and it's got the letters on the dice, I think that's a 26-sided dice unless some of the letters are used more than once. But we'll go 8-sided dice here, so we have 8 different outcomes. We need the probability of getting a 7 and then getting a 1. So our probability of getting a 7 to start with is there's only one 7 out of 8 choices, so that's going to be 1 out of 8. Our probability of getting a 1 is also 1 out of 8. Times those together, I've got a 1 and 64 chance. So the multiple choice answer to select in number 14 would have been D. This problem's got a chance to be pretty relatable to some people. I know it's relatable to me because I've got a whole drawer of socks at home, and I don't ever put them together after I wash them. So on any given day, I may have a blue sock and a brown sock on, but this really relates to that, and it's a little bit different than the other probability problems. And I want you to think about this for a minute. He wants to pick out 2 Argyle socks in a row out of all these socks that he has. Now, in all the other problems we've done, we have had our full complement of outcomes every time. So like when you roll a dice the first time, you've got 6 outcomes. When you roll the dice the second time, you still have 6 outcomes because you're not taking any of them away. This one is going to be different. This one, whatever sock we pick first, our outcomes are going to be 1 less because we won't use that sock again a second time. So that's just something to think about here. This is a little bit more difficult. So they want the probability of an Argyle sock both times. Okay, so here's what we got. We have 1, 2, 3, 4, 5, 6 Argyle socks the first time we draw out of the drawer of socks. Out of possible 6, 12, 13, 14, 15, 16, 17, 18 socks. Okay, so we have a 6 out of 18 chance of getting an Argyle sock the first time. Now here's where it gets a little bit different. We need to get it the second time as well, but you have to understand that we just picked one of those Argyle socks. So I've got to cross one of those Argyle socks off because I'm not going to get that back. Now we need to pick an Argyle sock the second time. So our chances of that are now not 6 out of 18, but it'd be 1, 2, 3, 4, 5. And it's not going to be out of 18 anymore because we already took that first sock out and we didn't put it back. So now we've got one less outcome. So it's going to be out of 17. It's not that much different, but it is going to change the percentage. So now I just have to multiply straight across. 30 out of whatever 18 times 17 is. Let's check it out here. 18 times 17 is 306. Now, to find that percentage of chances where this guy is going to get 2 matching Argyle socks on 2 blind choices, we just do top number divided by bottom number. So I'm going to do 30 divided by 306. 30 divided by 306 is 0.098039216. None of those other numbers matter for this. We just need the first two. So we got 9%. We could even make this 10% because we have an 8 here, which would probably say to round this up. So we'll round this up to 10%. So his chances of picking 2 of the same Argyle socks in a row is 10%. The thing to take out of this one is it's not quite the same the second time around as those other problems because we didn't put the sock back in the drawer because we needed the sock. We had to wear the sock. So we had one less sock to pick from. So instead of picking from 18, we're only picking from 17 this time. And instead of picking from 6 Argyle socks, we're only picking from 5 the second time around. Now, before I discuss 18, one point I want to make on the socks question and the last one on number 17. If the problem says with replacement, that means that you are going to put whatever you took out back. So every time you would roll a dice, that would be with replacement because you're not taking out any outcomes. If it says without replacement, that means that whatever you used, you don't put back. So that sock problem would be an example of not replacing it. So make sure you keep those two things straight. Now we're using coins here, so this would definitely be with replacement because every time we're going to have our 2 outcomes. Okay, you don't just flip a tail and then take the tails out and only have the heads. Okay, you're always going to have heads and tails. So this is an interesting question because you look at this and I think most people would probably say, wow, we've got to get 3 heads in a row here and we only have to get 2 here. This has got to be tougher to get than this. Okay, we got to see if that's right or wrong. Now, every single time I do this, each time I've got a 1 out of 2 chance of getting this. So that's just going to be, I have a 1 in 2 chance to getting ahead, 1 in 2, 1 in 2, 1 in 2. Down here, to get 1 in 2, 1 in 2, still 1 in 2, and 1 in 2. I have a 1 out of 2 chance every time of getting each one of these things. Because there's always 2 outcomes every time I flip, and I only have to get 1 of them. So I've got the exact same thing here that I've got here. So if I multiply this all together, that's going to be 1 out of 4 times 2 is 8 times 2 is 16. This one's also 1 out of 16. So if you thought before, because there were 3 heads that you had to get in a row here, and here you only have to get 2 in a row, you just have to think about the outcomes and how many is possible. We have the same chance of getting 3 heads and a tail as we have getting 2 heads and 2 tails, 1 in 16.